Okay, I'm just going to test the technology. Can somebody confirm that you can hear me and you can see my screen? Thank you, Matthew. We have a few minutes to go. If you have any questions, this is the time. All right, it is 6:30. I want to respect your time. Hello and welcome to week 5 of CQMS703. I hope your week is going well. Are there any questions before we start? Anything? Okay, last class, we did chapter 4, moving average and exponential and smoothing. Today, this week, we'll go over chapter 5, time series and their components. Next week, reading week, no class. And our test 1 is scheduled on March 1st. So that is week 6, March 1st. Test 1 covers chapter 1 to chapter 5. It is an online test on D2L. There are about 38 multiple choice questions, all multiple choice questions. Some multiple choice questions are concept. Some multiple choice questions demand calculations. Okay, toward the end, I will narrow down the topics for the test. Okay, after we finish the lecture today, I will give you some topics narrow down. So any questions? You can type in your question in chat area or unmute yourself, directly speak up. All right.
Sorry, Professor, just a quick question. I was just a little bit late coming on here. Chapter 5, is that included on the test or is it just 1 through 4?
Chapter 5 is included in the test. Test 1. Chapter 1 to chapter 5.
Thank you.
You're welcome. Any other questions? Okay. Just a little bit warm up. Go over one question from textbook. Okay. Question 8. Given the series in table P8, what is the forecast for period 9 using 5-period moving average? Okay. Question B, if exponential smoothing is used, smoothing constant 0.4, what is the forecast for time period 4? And C, what is the forecast error for time period 3 based on part B? So all these A, B, C, you will see those similar questions on the midterm test. So make sure you know how to do moving average, how to do exponential smoothing, how to calculate the error. Okay. Yes, Narina, questions?
I just have a general question regarding using Excel. So I've been trying to use it for when we create graphs regarding kind of 4-week or 5-week moving averages. And whenever I do that, it actually uses the time column as a separate variable. So it creates another variable using the time column if we're starting at, say, time 4 or something like that. And I was just wondering how I can change that and make that not a case, because it doesn't put the variable on the y-axis, it makes another line.
Okay, I'm going to do this question now. Hope it will help your question. If not, hold your question, remind me toward the end. I want to invite you to share your computer to see what I can do with it, okay?
Okay.
Yeah.
Thank you.
Thank you. All right, so pay attention to this ABC.
Sorry, Professor, I just had one quick question about the exam.
Sure.
Is there going to be a practice exam, or are we just going over the slides?
There is no practice exam. The format of the exam are multiple choice questions. I assume everybody know how to do multiple choice questions, right? So there is no practice exam, but I do have this list of topics here. It covers chapter 1 to chapter 5, but I would suggest you follow those topics. For example, at the beginning of today, I will go over moving average, exponential smoothing, and measuring the forecasting errors. Okay, the test question would be multiple choice.
Okay, thank you.
Okay, thank you for your question. We'll need SPSS on the test. You need to analyze the output from SPSS. There is a question about, some questions about autocorrelation coefficient. Yeah, here. So for autocorrelation coefficient, you could do it based on the calculation formula in the textbook, or you can do it on SPSS. this is probably the only thing you will need SPSS. But without SPSS, you can still do this question because you have the formula. There are examples in the textbook based on the formula. Okay. Any other questions?
Sorry, you can do the autocorrelation on Excel, can't you?
You
is it
can do
just
it on Excel, but you need to go over toward the end of chapter 3. Chapter 3, there is an example, but it is complicated.
So would you suggest doing it manually rather than on Excel? If
Yeah,
you don't have SPSS?
I would rather do manually rather than Excel, or use SPSS. Just a few minutes, few seconds when you use SPSS.
Okay, thank you.
Okay, and there are not so many questions, maybe just 1, 2, or 3, maximum 3 questions about calculation for autocorrelation. There may be some concept questions about correlation concept, but for calculation questions about autocorrelation, maybe 1 question, 2 questions, maximum 3 questions. Okay.
How many questions will there be on the midterm?
Total 38 questions, all
Thank you.
multiple choice questions. Okay. Any other questions?
Just one more. Would you be posting this on announcements or somewhere? Just an outline of the exam?
Yes, I will post announcement tonight or tomorrow after this lecture.
Okay, thank
Because
you.
next week, reading week, the week after reading week is our test. So I will post announcement. I will paste this message to you, okay? Any other questions? Okay, you still have chance to ask me about midterm toward the end when I finish the lecture, okay? I do plan some time to address your questions about midterm. So for now, I will start with chapter 5. And this question very important because it will be similar to midterm questions. How to do moving average calculation, exponential smoothing, calculate the forecast error. Okay. So let's do this question. First, we need to open the data file. Okay. The data file, I'm going to, this is a P. I'm going to open my file. Maybe I will open just some data file here. So it is chapter 4, problem 8, so PH here. Okay, so I'm going to, whenever you open the data file, you save it using different name. Okay. Maybe I will just save, okay. HTC driver. So this is a original file name followed by my name, initials. All right, so I save this data file as different name. So question 1, you are forecasting period 9. Okay, so maybe if you want, you can insert a time. So 1, 2, so that you know which one is period 9. Okay, so what is the forecast for period 9? Using 5 moving average, 5 period moving average, 5. So 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. So you do average 5, 1, 2, 3, 4, 5. Okay. By the way, during the test, please read the questions carefully. For example, this question asks you to forecast for period 9. If the period is not specified, if it is just say, what is the forecast using a 5 period moving average, you assume that is for the first period, first one, okay? So this one for period 9. If period is not given, you are assumed for period 1, forecast for period 1, or period 2 based on the context. Okay, so I did the 5 period moving average, and then you copy down. So this number is the forecast for period 5, is the answer for question A. Any questions?
Yes, Professor, we did this question last week, I remember, and I have it here in my notes. You forecasted for period 6 for cell 6 instead of cell 5. You just did it for cell 5, and so it was 212 matched with the 220 last time.
Okay, thank you. Some textbook actually use forecasting for 5 periods for the next one, so they do this. So they do equal average. 1, 2, 3, 4, 5. Okay, using this 5 period moving average as the next one. Okay, and then you drag it down. Okay, and other textbook said using 5 moving period for the period 5. Our textbook, let me double check. Our textbook, you are right. Our textbook follow this one here. Okay, so I'm going to delete this one. So the correct answer should be, this is the forecast for period 5. Okay. Any other questions? All right. Next question, exponential smoothing, and the smoothing constant is 0.4. 0.4. And what is the forecast for period 4? So for period 4. So let's start from the beginning. Okay, when you do exponential smoothing, you need to initialize the first and the second number. Remember? So the first forecast, y1 hat equal to y1. The second also equal to y1. And then the next one, yt plus 1 equal to alpha y, this is hat means forecast, alpha yt plus 1 minus alpha yt hat. So that is the exponential smoothing. You definitely need those formulas. Okay. And then, so the first one equal to y1. The second one also equal to y1. Next one equal to alpha. Alpha is 0.4 times YT. So this one is YT. Y2 is YT because I'm forecasting Y3 now. And plus 1 minus alpha is 0.6 times the previous forecast to 10. I pause for a moment so that you digest the formula. Any questions? Okay, so now you drag it down. And then the forecast for period 4. This is period 4, is this number here. Okay, forecast for period 4. This is answer for B. And then question C. The question just asks you the forecast error. Forecast error is the difference between forecast error for period 3, so should be here. Forecast error for period 3, it is equal to the actual number Y3 minus Y3 hat. Okay, so this number is the answer for question C. Okay, and this question is damping factor alpha. No, damping factor is 1 minus alpha. Thank you so much, Matthew, for answering that question. And thank you for asking that question. When you use Excel, damping factor 1 minus alpha. Okay.
Professor?
Yes.
I'm sorry to interrupt. Could you please go back to the E4? I just want to see the formula for that. E4. Yeah.
Sure.
Thank you.
You're welcome. The formula is here.
Professor, sorry, I just had a question as well. If you use the exponential smoothing data analysis in Excel, you get a different answer for B.
Okay, I'm going to use data analysis for question B. Exponential smoothing. Click OK. And input range. This is my input range from B2 to B9. Damping factor is 1 minus alpha, so 0.6. And the output, I will put the output maybe here. And I click OK button. The output, so 100. The reason is why we got different answer. See here, the first forecast value should be Y1. The second forecast value should also be Y1. I made a mistake. Thank you so much. The mistake I made is that the second forecast value should be Y1. Okay. And after that, you get actually the same result here. From I should put output in the I put output here. Okay. So this time you do the smoothing, you will get the same result. Thank you so much for your observation. So input range, it is B2 to B9 damping factor. And then the output should be put into the G2, not G3, so that you can line up with the manual calculation. See, those numbers are the same as this number here. Those two columns number are the same. Okay. Any other questions? And C equal to 11. What does C equal to 11 mean? Yeah, then the forecast error is 11, correct? Yes, Matthew. Okay. Any other questions? All right. So that conclude moving average exponential smoothing forecast error. Those from chapter 4. So today we will talk about chapter 5. Okay. So when you do the time series data, and if you put time in y-x-axis, and this is the production for this data, and you get this graph, looks like this graph is trending up, and the variance, you see, the data looks like constantly between those two lines. Okay, so when it is the changes are constant, although it is trending up, but the variance is constant. Okay, this is one situation. Another situation, if this is the time and you have sales data here, it is also trending up, but the variance, you see, is growing. It is growing. Variance is changing. It is not constant. Why we need to distinguish constant and non-constant? Because we want to use different decomposition. And why do we need decomposition for the data? Because we want to get insight of the data. Okay, after we get insight of the data, we make a forecast and then put the data together back to the original pattern. Okay, so based on these two patterns, we have two models. One is additive model, So the original data YT has three components: trend, T represents trend, and S is seasonality. I is a irregularity. Okay. So you use addition when data has a the variance are constant. You use addition, additive. And when data is variance is not constant, you use the multiplicative model. Okay, so original data is trend times seasonality times irregular. Okay, so this is a equation 5.1, 5.2 in chapter 5. The next, we are going to analyze this data. You cannot see it clearly, but I put out the Excel data in D2L. Okay. So this data, if I make it bigger, is about a data from 1960 until 2011. Okay, So let's take a look at this data. And this is about, let me see this data. Okay, so you get the idea of this data now. So what we are going to do with this data? This is actually core production data with the linear trend. If you go to D2L, you can find this Excel data. Now I'm going to open that data to create a linear regression equation. But first of all, I will create a line, the line chart here. So open the data. It is not here. I use another data. Chapter 5. Core production. Yes. So now I'm going to save this file. The name is core production. You have this data file on Excel. Okay. So it's from year 1960 until 2011. Okay. You cannot see all the number because you need to increase the width. So I'm just going to save this in different name. Add my initial. Okay, so if I delete this graph, just give you the original data, how do you create a line chart? You just select these two columns and go to insert and then line chart. Click OK button, you have this chart. Okay, and then if you want to write down an equation, you double click this line and toward the so right click your mouse, add trend line. Okay, and display equation on chart. Also R square is important, so I also choose R square. Okay. So you get this linear equation here. You can move this equation. Okay. So that is one way to get this equation. The other way, you can go to data analysis. And then you go to regression. Input Y range. So Y, it is from B3, I include label. So I include the label, that is Y. And X is from A3 to A55. and output, I will put it here. And then I click OK button. So this is the output. And make sure you know this output very well because there are several questions. So for midterm, you need to interpret the regression output from Excel or from SPSS. Okay, so I will use this example to explain this output. So the multiple R is the linear correlation coefficient. It is 0.97. Okay, so here is my X, and this is my Y. Y represents the co-production, X is the time. So there is a strong relationship between Y and X. They're close to 1. And R squared measures how much change in Y are due to X. It is 94.5% of changes in Y are due to X. Okay. And then you have the standard error. Standard error. This is how many data? 52 data. And for the ANOVA table here, you need to know all the number here. So start with the last one here. The significance is the p-value. And this p-value is E, -33. So this p-value is almost 0. Okay. When p-value is smaller than alpha, the model is significant. So this is a good model. We can use this model to make prediction. Okay. And this number is F-test statistic. F-test statistic equal to this 867 equal to MSR over MSE. So MSR is this number, 2.78 raised to power E 18. MSR is the mean square due to regression. MSE, mean square due to error. This number is 3.21 E15. Okay, so make division, you get this F-test value. And these two numbers are called, one is the sum of square due to regression. The other is the sum of square due to error. Okay, and the relationship between MSR, mean square due to regression, it is equal to sum of square due to regression divided by degree of freedom. We call that is K. K represents number of independent variables. In this example, we only have one independent variable, that is the time. Okay, and then you have MSE, mean square due to error. It is equal to SSE, sum of square due to error, minus divided by n minus k minus 1. So this 50 is n minus k minus 1. K equal to 1. N, this 52 is n equal to 52. Okay. So those are basic relationship among the ANOVA table. It is very basic. You need to know this for the midterm. Okay. And also, how do you write down equation? The equation based on intercept B0 and slope B1. Okay. So you can write down equation. Equation is production, or this is the production Y hat equal to B0 plus B1X. That is the equation. Plug in B0, B1 specific number. Okay, Any questions? All right. So this is we did that one. So we did this example, forecasting using the trend line. If you want to do the forecast for the next year, okay. For example, you want to do forecast for 2012. 2012 equal to B0. So B0 is 3E. That is a very, very big number. So plus B0 plus B1, this number times X is 2012. And you get the forecast. Okay, get the forecast for 2012, just based on this equation. Can we solve test question manually, or do we need to use SPSS or Excel? All the questions, you can solve it manually, except 1 or 2 questions need SPSS, 2 questions or 3 questions, maybe 1, 2, 3. Okay. Total, we have 38 questions. Just about 2 or 3 questions, you need SPSS. But many questions, you can use Excel. Okay, Excel is supposed to be available for everyone. Your computer is supposed to have Excel. Okay. Any other questions? All right. So this solves this forecast using the trend lines. Next, look at the textbook example about car registration, number of cars registered from 1960 to 1992. Okay, and if you open this data, car registration. I should have, is that? This one. It is not this one. Let's see. Car registration. Yeah, it is this data here. So it's about the car registration. Okay. So what are you going to do with this data first? You create a line chart to explore the data pattern. Okay. The result would be, you just go to insert line chart and you'll get this one here. This is the registration of the car from 1960 to 1992. Okay. So once you get this one, if you want to create a model based on this one, and you are saying, I want to use linear model, create a linear equation, y hat equal to B0 plus B1x. We just did one example of this model. Okay. If you want to use this model to this graph, it is not appropriate, because the more appropriate way would be maybe this model. If you use something, this model, it is more appropriate than use linear model. And this model we call polynomial. Specifically, it is a second order polynomial model. Sometimes we also call quadratic equation. Remember high school, you have ax squared plus bx plus c. We want to something like this. Okay, parabola. We want to simulate this parabola model, okay, based on this data. So to do that, you can use Excel, or you can use SPSS. Okay. If you use SPSS, you actually get this. Depending on what model, if you use linear model, you get this one, but this one is not appropriate. Okay, so that's why we are going to use so now I'm going to maybe open the Excel to illustrate quadratic model. How do you do quadratic model using Excel? Okay, I'm going to highlight the original given number. So those are the number given. To use a quadratic model, you need to create time, okay, time period. It is from 1 until 33. And then, so maybe I will delete all of this, do all the stuff from the scratch, so that you can see the process. So when you are given the data, you need to create a time series, 1, 2, 3, those are the time period. Okay. And then you want to use a quadratic model. So you time square. So this number square. Copy down. Okay. So what you want to do y hat equal to b0 plus b1t plus b2t squared. You want to create this quadratic model. Okay. So now you go to data analysis, regression, click OK button. So y is from C1 to C34. And then input x range, I have 2x here. One is t, the other is t squared. There are 2x. Okay. So x, you select t and t squared, 2 columns, select together. As you can see, I included the labels. Output range, I want to put in maybe output. I want to put maybe here as my output. Okay. And then I click OK button. Range will override existing data. Okay. So this is my output. Okay, from Excel. Make sure you understand all these numbers I just explained. Make sure you understand all these numbers I explained. Okay, so now I'm going to write down equation based on these 3 numbers.
Sorry, Professor, could you just show that the data analysis, how you got that again? I was trying to find the zip file.
Okay, no problem. So once you get the zip file, you have this data, right? And then you need to create a time period from 1 to 33. And then square this time period, you get t squared. After that, you go data analysis, regression, select y. Y is from C1 to C34. X, you need to select 2 columns from D1 or D1 to D34. X, you need to select 2 columns, column D and column E together. That's it. you specify an output, you click OK. Can we do second order regression with SPSS? Yes, we can do second order regression with SPSS after using Excel. Okay. Any other questions? All right. So this is the output. And based on this output, you can write down the equation. Intercept 6.356 plus B1. B1 is 0.348 times T. B2 is negative 0.008 times T squared. Okay. So you get this Y hat. This is a Y hat. And if you are asked to forecast for year 1993, you plug in 34, T equal to 34, T equal to 34, you get a value. That is Y hat, prediction for Y. Okay. Any questions? All right, shall we all take a break? After break, I will do this same example using SPSS to do the second order regression. Okay, so back at 7:30. I'm going to stop recording. When I come back, I will start recording again. Stop recording.